Okay, in a previous video, we saw how to construct flow paths in a model that consisted just of a single layer. We used the flow paths to identify a local flow system. And now what we're going to do is extend this to a three-dimensional model with multiple layers. And so the idea is we have a watershed here that consists of these streams within the watershed, and we're just going to idealize the streams with a very simple network like this one. This is a main channel, a second order channel, and these would be, say, first order tributaries coming off it, like so. Just like, for example, up here we've got a second order channel here, and then first order tributaries coming off it. And these are the hydraulic heads in the streams shown at these various different points, and we use the same strategy that we used last time, where we put arcs down along the streams and give the elevations of these points along the arcs. So we have a model that is going to look very much like this. Now, the difference, though, when we go to 3D is that we'll want the lines that represent these streams to actually be inclined in three-dimensional space. So this line will go from 200 to 205 to 210 meters in elevation. And so if our model has layers that have layer boundaries over this, between this interval, then the boundary condition that is representing the stream has to cross from one layer to another layer. And so that'll be one difference that we'll have to account for. We'll also have to account for the starting positions of the points that we're using for the path lines, because we won't be able to put in starting points that are above the water table. In this software, we can't do the particle tracing above the water table, only in the saturated zone. And if we do that, then those particles will just simply be ignored. Okay, so what we're going to need to do when we set up these streams, we'll still set them up just as constant head boundaries. We'll still do that approach, but we need to be able to tell the code that it's okay to have the boundary conditions cross the layers, and in fact we want the boundary condition to be in the appropriate layer. And it's kind of tedious to figure out the appropriate layer by hand, so we can have the code do it. And here's how we'll go about doing that. When we go in and in the coverage, we put in a coverage that represents the streams, and in that coverage we have a coverage setup that we'll open, and we need to check. There's a checkbox over on the left-hand side in the same column as the constant head boundaries. There's a checkbox called layer range, and this will allow the boundary condition to span multiple layers. And then in the attribute table, we open the attribute table and we select arcs, and then we get something that looks like this, the properties. This is cut out of what we see for the attribute table. And we've already set the specified head here. We've already seen how to do that. But if we select this layer range, then we get this column here. And there are a couple of different selections that we can make. But if we use this one, auto-assign boundary condition to one cell, then the code will assign this arc to the grid block that is the appropriate one for the proper elevation of this boundary condition. There are a couple of other selections here, and you should read about them in the help for GMS. Okay, so we're going to set the code up this way and run it, and then we'll also do particle tracking in this three-dimensional model. so we go over here to the model, and before we get started, we're just gonna, I've got it set up here, but before we run that, what we're gonna do is just assume that we're starting with a new grid. Okay, so let me first start making this grid. So we'll take the grid frame and we'll map it into 3D. And one thing, okay, actually, before we do that, what we want to do is have this three-dimensional grid cover both below the ground surface. Well, it's going to be below the ground surface, obviously, but the ground surface here is irregular, and we're not quite sure where it is right here. It's 200 meters here and 210 here, and it gets even higher here, 215, and we might imagine that there is a mound or ridge here where it's even higher. So we need to make sure that the grid extends up high enough, and we also need to have it go low enough to include the flow system. So when we start up our grid frame, we need to make sure that it covers enough territory. So we're going to delete the grid that we had and go here and use the same XY grid that we just had, so 80 by 72. And vertically, what I've been doing is starting at 175, so 25 meters below this lowest topographic point, and making it 75 meters in thickness, so it goes up to 250. So that's plenty high enough to get above the ground surface here. So a good bit of these cells will be dry. And then for the number of cells, this is the number of layers, then we should have, let's try 15 layers. Okay, so we've made a new grid, and now we have to go and put ModFlow back in there. And what I'm just going to do right off the bat, because I know that this is going to be needed, is to set the initial heads to 250, just high enough so that they're above the grid. Otherwise, if we don't do that, then there will be cells that start out dry, and they'll be taken out of the computation. And in fact, all of the cells will be dry, and there will be no computation. So if you do this, and if you work this problem or other problems that have positive elevations, and you get no solution at all, then it could be because the initial heads are below all of the grid cells. Okay, so okay. Let's look at the streams here. I've put in the streams already. I put in these lines, and I put in the breakpoints. It takes a little while, and it's not worth spending time on that because you've already seen how to do that. But what you haven't seen is the coverage setup. And here's the coverage setup where I click the specified head, and I click here the layer range to get this three-dimensional aspect of the constant head boundaries. And then I also give a broad range of layers here, and we might just include all the layers, although we're really only going to need the upper ones, but we're not quite sure how many of them there are, so we'll just include all of them here. And then we'll also take a look at the attribute table. So if we select arcs, then here are the types. They're specified head, and they're this auto assign layer is shown here under the we also have these other selections, but to do what we want to do with these streams, we'll use auto assign layer. And then we can also take a look at the nodes. This is where we have the elevations, and so I've just gone through and selected each one of these nodes and given the elevation So that should be something that you're already familiar with. Okay, so we can check this, the recharge. We're just going to really start off with the baseline analysis. 10 to the minus 8 meters per second, 10 to the minus 6 meters per second for the hydraulic connectivity. Okay, so let's go ahead and run this. We can check it first. If we run the check, we have some warnings here, but let's go ahead and run it and see how it goes. I think this will be okay. Okay, so you can see here that we've got some iteration, mod flow finished, looks okay. And I toggle off the display, so I'm going to put that back on. And here is the display in layer. Here we go. There's the display. Okay, so that's what we get. And if we click here for the orthographic mode, then we can look at it by layers, and these are the different layers. And what we see right here is this is just blank, and so this is a place where the water table is. This is basically where the water table is below the cells that are right here, and so these cells are dry and they're not used in the analysis. And so we can go to some deeper layers and we can see how this the dry cells are. We just have a few dry cells here, and we keep going a bit deeper, and now we see that all the cells are saturated, and we start to see the boundary conditions showing up here. So these are the streams, and we can scroll through. Let's go there. Actually, there's in layer 8, there's just the headwaters of this stream, and here, and some of this stream. And then if we go to the next layer down, we get some more stream here, going further down the gradient, and we go further. This is now to layer 10. This is deeper, and we see more of the stream here. So these streams are definitely spread out onto different layers. Okay, so let's take a look at this in a perspective view. Well, actually, I guess before we leave the ortho view, let's try looking at it in cross-section. Here it is in cross-section, and let's kind of zoom in on this. Okay. So there's the cross-section. This is in row 64. So this will be up kind of along the top of the model. And you can see the streams, and you can see the so here are the three streams, and you can see now we're going into the middle of the model. This is right here at the divide, and we can continue going down. We should pick up some more stream channels now. There, okay. So here are the stream channels, and then here's the water table. and I'm not quite sure why it's showing this irregular edge. Looks like it draws the water table in, but this perhaps could be some instability in the solution, or it also could be just a graphics, a plotting thing. I'm not really quite sure. Okay, so let's also take a look at this in a perspective view. So here's the, if we click on this button right here, it's called oblique view, and we can drag it down here and zoom in, and we see what this thing looked like in 3D. So here's this ridge of high heads, and this is now the water table. Okay, so we see at least one view of the, basically what this is the hydraulic heads that are sliced at different elevations. And the purple here is the streams, so you can see how the streams are manifested in these different layers as we go up in elevation. We can kind of rotate this around. And here's this main first order stream that we've been really focusing on, and you can see now in 3D what this thing looks like, how it rises up here in elevation, and then we've got these ridges or mounds of groundwater in between the streams. Okay, so this oblique view kind of helps out with visualization a bit. But when we set the model up, it's going to be better to use this orthographic projection. And so here we are looking down on it in this layer 10. And so what I'm going to do is scroll up here to layer number 1, and this shows really just the highest ridge of the water table. And what we'll do now is to include the path lines, and we'll try to come up with what the boundaries of the local flow system are. Okay, so the procedure is to go and I've erased the starting points that we were using last time. So go to this coverage, the starting point coverage, and then we'll include some points here. And let me just show you this effect. So I'm going to put in a line of points here. And these points aren't showing up, but I'm clicking there where this ridge is. And if I turn this off, we can see it. So there is indeed this line of starting points. And so these points are in layer number 1. Okay, so the procedure now is to select these points, right click, select intersecting objects, hit OK, and then go and generate these particles at selected cells using ModPath. This will actually now run the ModPath calculations, and we can see now these paths that are formed, and only the particles that are in saturated ground are used. Okay, so that I think makes sense. ModFlow is really only doing analysis in the saturated ground. So it could be helpful to take a look at this in perspective view. So we'll click here, and you can see here's our points that are starting out right along a ridge. And let's kind of pull it down here. And we should be able to see these flow lines if we kind of look at it sideways. Yeah, there they go. So we have some recharge coming in here. It goes down and discharges to the streams, and some of them along this side, the north side, this is right along the divide, right? So along the north side, these points go to the stream up to the north. Okay, so that makes sense. And what we've done is to create over here this entry that's called particle set. And this is, if we click this and we turn off the path lines from that particle set. So conceptually what we've done is we put the particles here in this map data, and if we turn this off, then the points that all those points that we put in get turned off. And when we went and selected those points and then made them into mod path starting points, then those points got made into this data set. And basically this particle, these guys are just the particles that are used as starting points. So when we click this off, the points here that are used as starting points get turned off. These points never were used, so they're not turned off. Okay, so let's try doing this. Let's try going now to layer 2. And what we're going to do is we go down to layer 2, and we go back here to these starting points, and I'm going to turn this off. And so now I'm going to select all of these guys and right click, and sorry, they got unselected. So right click, there's select intersecting objects, okay, and then make them path starting points for paths. Hit OK here, and now we have another particle set, and we'll turn this on. Okay, so now what we've done is we've made a particle set that is, so we're still starting with this same straight line of points, with the same set of points, but now all of the points that are below the water table along this line are used. So we're basically mapping these points into layer 2. Okay, so yeah, and what we've done is we've stuck with the same particle set, so we can either turn this off or turn this on. So here's what I'm going to do. We might want to see which particles are in layer 1 and which are in layer 2. So what I'm going to do is I'm going to change the name of this guy, and these are particles in layer 2. And I'm going to go in and add another particle set. Select that one. Okay, and I'm going to go and I should have done this, should have added this particle set before I made this last operation. But what I'm going to do is go back up here. I'm now in layer 1, and I've selected this particle set here. And I guess I'll turn all of these off. Here, starting with this set of starting points. And go through this procedure that I've done now several times, where I select this, right click, select intersecting objects, OK, mod path, generate particles, OK. And click this on, and now I have these particles from, let's change the name. Particle set layer 2, layer 1. Okay, so now we can turn this layer off. So we just see the particle, the particle traces here, the flow paths that are from the particles that are in layer 1, and here they are particles that are in layer 1, essentially layer 1 and layer 2. So it's probably hard to see, but let's see, if I turn this off, let's look like right here. Yeah, so when we turn this layer 1 on, you see that I get right here. Take a look at, these are two flow paths that are from these particles when those particles are down in layer 2. And when I click here, I get additional flow paths. And in this perspective, those paths are nearly overlapping, but not quite so. And so we see that that line is a little bit thicker. Okay, so that's from these two particles that are really right directly overlying these two in these two different layers. Okay, so this gives us some flexibility here in putting out multiple particle sets and turning them off and turning them on. And there's a lot of flexibility here, so this will be useful when we try to understand what the flow system is doing. Okay, so what we want to do now is try to understand what the capture zone is like. Okay, so probably what we should do is put in some particles in different layers. And this has become a much more complicated problem than we had before because it's a three-dimensional problem. And so we want to put in particles in different layers and come up with what the capture zone looks like. I'm going to take a bit of a shortcut though and just go down to say layer 7. Layer 7, now we're deep enough so that if we go to the same level as the outflow point here, everything up gradient is all saturated. So let's just use that, and we'll this layer, and we'll put in a new set of particles, and we'll go down here to our starting points and turn this coverage off. So I don't really like those points as starting points, so I'm going to well, let's keep them. We might want to use them for some other purpose. So what we'll do is switch to a new coverage, and let's call this start points 2. So you see these guys are gray, so we can't really, if we click on them, we can't get access to them, but we can still see where they are. So now we'll use these as starting points, and let's just check coverage setup. Yeah, so this looks like it looks good. We don't have to check anything here. Probably want to have this be over the full range. And so now we can go and put in these points. So let's go in here and just click around here. We can put in, if we put in a polygon and select a polygon, then it'll put a point in every grid block. And that can be convenient. You can try doing that. But it will make quite a dense set of flow lines, and it may be just overwhelmingly dense. So I'm just going to put in a lot sparser set of points here. So we go and select it, and I'm using this arrow for select objects, and then selecting them with a box, and then going up to my path, and we're still having them start here on the water surface. Although, actually, well, we'll take a look and see where they start. Okay, so we ran that. We want to select that particle set, and we show these 3D grid data. So there they are. This looks kind of like what we started with last time. And we can turn off these particle sets here. So these were the ones that we did last time. This is the new one, and there are the new particles. And these were put in layer 7. So if we go over here to click this to turn it off, and then click this to turn it on, we see our model. We can see down here the projection of the 3D model. And let's bring this over here and zoom in, and then rotate it around by selecting that point. And you can see that this now, all these points are starting in this layer number 7. And so they all start here, they converge down to the stream and some of these other streams. And we go and turn on these other particle sets that we put in starting up here in these higher elevations. So there they are. And we can start to see now this three-dimensional nature of the flow system emerging. So really now what we're seeing is that this local flow system will be bounded by a surface in 3D that is the capture zone surface. And we can see there's probably a divide right here that curves down and forms the trace of the surface would look something like this. Okay, so for our purposes though, what we can do is again just go and trace out the boundary like so, and get an idea of what that looks like here, and keeping in mind that a line that we draw here is really just going to be the trace of this surface that defines the boundary of the local flow system. All right, so that is, I think, really what I want to show. Yeah. Notice that when we've done all of this, we haven't had to go here and activate this cell-by-cell flow. The code is able to go and recover out the data sets. Sometimes when you run this, it will give you a message and say that you need to go and generate these data sets. And if that's the case, you would do this. So just keep that in mind. It seems like sometimes you need to do this and other times you don't. Another thing that would be good to do is go through and take a look at some of these options, the display options. For example, it gives you various things that you can do. You can toggle the ending locations and starting locations and change around what everything is looking like. There's a good bit of flexibility here, and so depending on what you want to show, you can tailor it to your needs. You should also look at these general options about how ModPath is set up, and there are also some different procedures for using wells for these particle tracing, and actually that's covered pretty well in the video, the YouTube video that GMS has done. They do an example that has wells in it, and so I thought I would focus our example on one that doesn't have wells. So you should look at their video to see about the case where wells are used.